Okay, so now I want to talk a little bit about exponent rules. Again, this is just for review, but it's topics that come up repeatedly through the course. And when we think about an exponent, well, first of all, let's back up for a second. Let's think about multiplication. When I do something like 2 times 3, that means I want to do repeated addition. So 2 times 3 is the same as 2 plus 2 plus 2. And just like multiplication is repeated addition, an exponent is repeated multiplication. So 2 to the third power is equal to 2 times 2 times 2. So if we think of this first example, 2 to the third times 2 to the fifth, it's like 2 times 2 times 2 times 2 times 2 times 2, and then I got 5 of them in the second parentheses. If I add those up, then I'm going to get 2 to the 8th power. And in the next one, I don't have multiplication, I have division, but the process works the same way. I'm going to do 4 times 4 times 4 on the top, and I'm going to do 4 times 4 on the bottom. And now, instead of adding them all up together, I'm going to subtract them because division cancels things out. So now I have 4 times 4 times 4 on top, and I cancel 2 of the 4's out, and I'm going to have 4, or 4 to the first power. Next one is just with variables. I have x times x times x times x times x, and that's x to the 5th power. On the 4th problem, if I write it all out, I can just, instead of writing it all out actually, I can just kind of look at it and I can see that now I'm going to use the quick rules, which is if it's multiplication, you're going to add the exponents. If it's division, you're going to subtract the exponents. In this case, I have 2 x's on top and 3 on the bottom. So I just kind of picture what's going to happen. 2 of the x's on top are going to get canceled, and there's going to be 1 x left on the bottom. And when I look at the y's, the same thing that's going to happen. There's 3 y's on the top and 5 y's on the bottom. So that's going to leave me a total of 2 y's, and those 2 y's are going to be in the denominator of the fraction, or the bottom. And then the question of what goes on top. Do I put 0? It can't be 0, because 0 divided by anything is just going to give me 0, and this has a value. So when they cancel to 1. Now, there's another rule called raising a power to a power. And so if you think of, if I have x squared, that's x times x, right? So if I have 3 to the 4th squared, it's going to be 3 to the 4th times 3 to the 4th. And that equals 3 to the 8th. So when I raise a power to a power, I multiply the exponent. And in this case, I'm just going to do the quick way, and I get x times x to the 2 times 3, which is 6. And I get y to the 3 times 3, which is 9. Now another rule that you have to know is anything raised to the power of 0 is not 0, it's 1. In fact, if you want it to be, it's a big fat 1. And anything raised to a negative power is going to be negative. It's not going to be a negative, it's going to be a fraction. So when I have x to the negative 1, I get 1 over x. If I have 2 to the negative 1, I get 1 over 2. If I have 5 to the negative 2, I get 1 over 5 squared, which is 1 over 25. If I have 2 to the negative 3, it's going to be 1 over 8. Now if I have 1/2 to the negative 2, this is interesting. If I have a whole number to a negative power, I get a fraction. So if I have a fraction raised to a negative power, what do you think I'm going to get? I'm going to get a whole number. Okay, so now let's do some examples where you have powers raised to the powers, and they get a little bit tricky, but you can rewind this and you can rewatch it. So first of all, there's an implied, when I don't see an exponent above a number, there's an implied 1. So I have 4 to the 1, x to the 4th, y to the negative 2nd. Now I'm going to distribute that 2 into all of those exponents. So I'm going to get 4 to the 2nd, x to the 8th, and y to the negative 4. And if I rewrite that, I'm going to get 16 x to the 8th divided by y to the 4th. So 16 comes from 4 times 4, which is 4 squared. Now in this last one, which is tricky, what I'm going to do is I notice that I have a negative exponent on the top and a negative exponent on the bottom. So one convenient thing that I can do, if I want to make it easier, is I can move the negative exponent on the top to the bottom and make it positive. And I can move the negative exponent from the bottom to the top and make it positive. So in a sense, my first step is just going to be to flip the numerator and the denominator and get rid of these negative exponents on the -2 and the -1. So I have 2x to the -2, y to the -5th. You see what was on the bottom is now going on the top. And I have 8 8x squared y cubed to the second. And now the negative became a positive. And next what I'm going to do is I'm going to keep the top how it is because I want to raise that power to a power on the bottom. And I'm going to have to raise 8 to the second, x to the fourth, y to the sixth. I'm just multiplying everything by 2. Now I'm taking all the negatives. First of all, I'm going to evaluate 8 squared, and I'm going to take all the negatives that are on the top, and I'm going to move them to the bottom. And so if I picture what's going to happen with the x's, I'm going to have x to the fourth and x squared on the bottom, and I'm going to have y to the sixth, y to the fifth on the bottom. So lastly, all I have to do is put the x's and the y's together. I'm going to have 6 x's, and I'm going to have 11 y's. And then 2 divided by 64, well, I can simplify that. So I get 1 divided by 32, x to the 6th, y to the 11th. And that's my final answer.